right, good day everyone, and welcome back to Free Edge Drop. Hope you're enjoying your day. So today we are going to be looking at the topic Pythagoras Theorem. So we're going to be learning about Pythagoras Theorem today. And for those of you who have not subscribed to our page, please I advise that you subscribe so you can learn more, and also like our page on Facebook. Very important, so you can get more information from there too. All right, so we should begin this topic. And first of all, what is Pythagoras theorem? This is a theorem in which you use to solve questions concerning right angle triangle in mathematics. You know, mathematics have different type of triangles. You have equilateral, isosceles, and you have right angle triangle. You have other types. So for this right angle triangle, there is a theorem called Pythagoras theorem in which you use to solve only right angle triangles. It doesn't work for equilateral, it doesn't work for any other one. Only right angle triangles. Now, as you can see here, this is a right angle triangle, and it always has a base angle of 90, an angle 90 over this place. This is what makes it a right angle triangle. It always have an angle 90 at one side. Any triangle which has an angle 90 at one side like this, even if it's upside down, but it has this angle 90, it's a right angle triangle. And this rule that I'm about to show you can apply. So now this is how Pythagoras theorem works. First of all, you have to understand the right angle triangle before you can even use the theorem. Now you see this side labeled A. As I have written, it is called the hypotenuse. The hypotenuse is usually the longest side in any right angle triangle. It is the longest side, and it always faces the right angle, like angle 90. Let me write that out. It always faces this angle 90 here. You see, it always faces the angle 90, and that's how you know the hypotenuse. It's the longest and it faces the angle 90. Not this, not this. That is how you know the hypotenuse side, the longest side, so that's for that. And then you have the adjacent. The adjacent side, which is labeled B, that's here. The adjacent, that's the name. And the other one is called the opposite, the last, which is labeled C. Now I will explain why this is called the adjacent and this is called the opposite. Actually, it can change, but this is why it is called adjacent and opposite. Now, if you look at this angle here, this is theta, an undefined angle. It is facing this line C, or the side C, and that is what makes it the opposite. It is opposite to this angle. That is why it is called opposite. If the angle, this angle was here, and it faces the B will be called the opposite. You understand? So in another question where the angle is here, the B can be called the opposite, and then the C becomes the adjacent. But the angle is here and it faces C. C is called the opposite and B is called the adjacent. So that's the easy way to know them. Wherever the angle faces, this one, not the angle 90, the angle 90 faces the hypotenuse. But wherever this angle theta here, which is not known, faces, it is called the opposite. Why the last side entirely called the adjacent? You already know your hypotenuse, the longest. You check for the angle, you know your opposite. So the last one becomes your adjacent. It's as easy as that. So now you understand this part, and we're going to move to the Pythagoras theorem. Now you have two major formulas, or two major theorems, or two major shortcuts which you can use in solving questions on right angle triangle. It could be more, but I will show you two easy ones in which you can use in solving questions on right angle triangle. The first one is this. Now you see what I've just written. A square equal to B square plus C square. Now that is what you can see here. A is for hypotenuse. So what I'm trying to say with this formula is that hypotenuse square is equal to what is B? Adjacent. Adjacent square plus C, opposite square. So when you have a number here, for example, they give you a number at B and they give you a number at C, and they say find A, which is the hypotenuse. So the square of this number which you are looking for plus, equal to the square of b plus the square of c. So when you square these two and add them together, you will get the square of this. When you square the adjacent and the opposite, adding them together, you will get the square of the hypotenuse. I will show you some examples to explain how that works. Now, I'll be showing you the second theorem, which is this. It's a shortcut which was developed, and you can know it like this. Now you see it. So you can call it SOHCAHTOA. It is used by most students which know this shortcut, and it's very easy just for cramming the formula. And the first one here means, the S means sine theta. The S means sine theta, which is equal to, O means opposite over the H means your hypotenuse. Are you seeing it? So the O means your opposite and the H means your hypotenuse. Now for the second one, the C means cos theta. And the A means your adjacent over the H means your hypotenuse. Now for the last one, your T is your tan theta equal to your O is your opposite and your A is your adjacent. Now, this is for the second formula. Now, I will quickly explain why there are two formulas and when you use the two formulas. Now, for the first one, you see this angle here. We have an angle here which is not known. Now, for the first formula there, if they give you B and they give you C, that is when you use this formula to solve. For example, they say find the hypotenuse when B is 2 and C is 3. Now, you simply say, okay, your adjacent is 2, your opposite is 3. You put them in this formula, which I'll be showing you some examples on how you do that. But that is when you use this formula. This angle must not be known to use this formula. You understand? This angle here must not be known to use this formula. But you know there is always 90. This angle is always 90. But this must not be known to use this formula. And for this second one here, you have sin theta equal to opposite over hypotenuse. What this means is that even if you know only one of the side, you can use this formula. But this angle must be known. This angle must be known. For example, you have, they said they gave you this angle as 20. For example, they gave you this angle as 20 and they gave you C as 2 and they said find B. They said the angle is 20. I can see the angle is facing C, which makes it the opposite. And then they said find the adjacent. They gave you only one side and they said find the other side, in which you don't have the hypotenuse to use this formula. Now what do? You have 20 here. Now this is opposite and this is adjacent. Which formula connects opposite and adjacent? Opposite and adjacent. Opposite and adjacent. You see it? So this is the formula that connects opposite and adjacent, which is tan theta. So what you simply do, you take tan theta, which is tan 20. Tan 20 will be equal to the opposite, which they gave you as 2 over the adjacent, which you are looking for. You see the trick now? The opposite over the adjacent, which you are looking for. So for this kind of questions, you don't really need all the sides. But for questions without this theta, or without the angle here, or without the angle here, you have to use this formula. So these are the two basic formula in which you have to know while using Pythagoras Theorem. And I will need to show you some examples. I will need to solve some questions in which you are going to see how you use every of these formulas, when you use them, how to use them. So I'm going to be showing you some examples, or I'm going to be solving some questions. So I'll just advise that you please subscribe and you check out the next video, in which will be the part 2 of this Pythagoras theorem, and I'll be showing you how to solve questions on this Pythagoras theorem. You already understand the explanation, but if you don't, please just wait for the question segment where I'll be showing you the examples that will make you understand more. Thank you for watching this video. Please subscribe, like our page on Facebook so you can learn more, and thank you.